chances are you've already used one today, maybe to help draft an email, search for an answer, or even to write a bit of code. They're called large language models, and they are, without a doubt, reshaping our entire digital world. So today, we're going to pull back the curtain and demystify the magic behind the machine. We'll look at what they are, how they learn, and, most importantly, why it all matters to you. So, where does this technology actually pop up? Well, the best way to really get a handle on large language models, or LLMs for short, is to realize this isn't some sci-fi future tech. Nope, it's already woven into the tools that you and I use every single day. I'm going to go out on a limb and guess that for a whole lot of you, the answer to that is a big yes. Just think about it for a second. Maybe you were trying to clean up an email, or you were stuck on a tricky piece of code, or maybe you just asked a random weird question you thought of. Odds are you were talking to one of these incredibly powerful AI tools. Now, here's the thing. All of these different apps from all the biggest names in tech, they all share the exact same DNA. They've all got the same engine under the hood. And that engine, as you can see here, is the large language model, the LLM. It's what's driving this entire revolution in AI. Okay, so we know they're the engine. But what is that engine, really? What exactly is a large language model? And how in the world does a computer learn to talk our language so convincingly? At its core, an LLM is a kind of AI that's built on a deep learning model. And believe me, the large part of the name is no exaggeration. These things learn by reading a mind-boggling amount of text. We're talking a huge chunk of the internet. But the real secret sauce, the big breakthrough, is an architecture called a transformer. That's what gives it this incredible ability to understand how words relate to each other in a sentence. If you're going to remember one thing from all this, let it be this quote. It is so tempting to imagine some kind of thinking machine, like in the movies. But the reality is actually way simpler and honestly, way more fascinating. At its very core, an LLM is just a giant statistical prediction machine. Think of it as the most powerful predictive text you've ever seen. And this distinction is absolutely crucial. An LLM doesn't understand things the way we do. By analyzing trillions of words, it's just become an absolute master of probability. It isn't thinking, it's just calculating. What is the most likely word to come next in this sentence, based on every pattern it has ever seen? It's just statistics on a scale that's almost impossible to imagine. So how does a machine get so good at this prediction game? I mean, how do you go from a totally blank slate to an AI that can write poetry or debug computer code? Well, it all comes down to a really intensive and fascinating training process. So it all starts with data, a library that contains a massive portion of the internet. First, all that text gets chopped up into these little machine-readable pieces called tokens, kind of like digital Lego bricks. Then, that special transformer architecture we talked about analyzes these tokens to find relationships between them. You can almost picture it like a giant switchboard with billions of tiny knobs, which are called parameters. The model just keeps adjusting those knobs over and over and over until it's mapped out the statistical patterns of human language, everything from basic grammar to complex ideas about the world. And right here, this is the real game changer. It's a key part of the transformer called the self-attention mechanism. See, older models, they really struggled with long sentences, but a transformer can look at all the words in a sentence at the same time and figure out which ones are most important to each other. So in a sentence like, the robot picked up the ball and threw it, self-attention is what helps the model know that it refers to the ball, not the robot. That ability to grasp context is what makes these LLMs so incredibly powerful. So we've got this incredible prediction engine. So what? What does that actually mean for us in the real world? Let's take a look at the practical applications that are just exploding right now. And their versatility is just staggering. I mean, in the creative world, they're drafting emails and generating entire articles. For developers, they're writing and fixing code. In the business world, they're powering customer service chatbots. They're summarizing 100-page reports into a single paragraph, analyzing customer feedback, and translating languages in real time. It's pretty wild. Now, it's also really important to know that these models come in two main flavors. On one side, you have the proprietary black box models like OpenAI's GPT-4. A company owns it, and you basically pay to access it as a service. But on the other side, you've got open source models like Meta's Llama. Anybody can download these, modify them, and even run them on their own computers, which gives you way more control and transparency. But, and this is a big but, for all of this exciting potential, we have to be clear. This isn't magic. These are incredibly powerful tools, but they are also deeply flawed. And understanding their limitations is every bit as important as understanding what they can do. And that brings us to the really hard questions. What happens when a statistical prediction machine, no matter how good it is, just gets things wrong? And what are the hidden costs of building this technology so deeply into our day-to-day lives? There are three huge challenges we really have to face. First, something called hallucinations. This is when the model just makes stuff up, stating completely false information with total confidence. Second is bias. Because these models learn from the internet, they also learn all the biases, good and bad, that exist in that data, and they can even amplify them. And finally, there's the staggering resource cost. Training these models takes an enormous amount of computational power and energy, which raises some serious questions about their environmental and financial impact. So we come all the way back to where we started, predicting the next word. It seems so simple, but it's the foundation for everything we've just talked about. And as these models get smarter and more powerful, the big question isn't just what are they anymore, it's what will they become? What happens when predicting the next word evolves into predicting the next action, or the next scientific discovery, or the next brilliant idea? That is the truly transformative future that we are all stepping into, one word at a time.